Okay, so we're simplifying these square roots, right? The first thing that we need to notice is that this radicand, which is inside our radical, is not a perfect square root. If it's not a perfect square root, then we have to factor it. So we can factor 72 by saying, what multiplies to get to 72? Well, 8 and 9 multiplied to get 72. Then we look and say, okay, is 8 and 9 prime numbers? And no, they're not. So then we have to break them down even more. So 9 we can break down to 3 and 3, and those are prime numbers. So those are good numbers. So we're going to circle them because we're going to use them. 8 can be factored into 2 and 4. 2 is a good number. It's a prime number. But I have to remember that 4 can be broken down to 2 times 2. So we have to break down 4. Okay? You have to double check to make sure that all of these numbers are prime and they are your last numbers that show up. Now your job is to match them up. So you will match them up by which ones are alike. Well, you have a pair of 2s that are alike, and you have a pair of 3s that are alike, and they like each other so much, and they're just alike, they're gonna go out on a date. They're gonna leave their radical house, and they're going to go out on a date. The pair of 3s is gonna come out of the house because the pair of 3s is going to travel in one car. So we're only going to write the 3 one time. The pair of 2s is going to get to go out on a date. And we're going to write the number 2 one time because they're using one car. So I split them up because these two have to be multiplied together. I have one number who does not have a pair, who's all alone, and he has no date, so he gets to stay in the radical house, which is called the radicand. Okay, this problem is slightly different because we do have a variable inside the radicand. Okay, the easiest way to figure out what you do with this variable is to write out how many of this variable you have. It says x to the third power, so I'm going to write out how many x's I have. And then I'm going to use the same thought process that I used down here. How many pairs of x's do I have? I have one pair of x's. So that one pair of x's gets to come out of the radical and go on a date. So that one pair, and it still is the same rules apply. If they're going out on a date, you only write one of them. So I can put the x over here, and I'm only going to write one of them. Well, this other x, he has no date. And anybody that has no date is going to stay in the house. And we separate the two by multiplication. So when we go to simplify these, we are going to simplify them by multiplying. So we have 2 times 3x, which is going to give us 6x, square root of 2x. And that would be our simplified version. And how you say this is that you have 6x multiplied by the square root of 2x. And that's how you would verbally say this. 6x multiplied by the square root of 2x. And this was our bachelorette radical style. What did you guys think of that? So we are going to simplify the square root of 45, x to the third, y to the fourth, and x to the fifth. Okay, when we simplify these, the first thing that we are going to ask ourselves is the radicand, which is inside the radical, is it a perfect square root? No, it's not a perfect square root. So your next step is to factor it. It's like the factor dating game, because we're looking for pairs to pull out. Okay, so 45 can be factored into 5 and 9, and 5 is prime, and 9 can be factored into 3 and 3. So far, so good, because we have one pair that gets to go outside of the radical. So he's outside of the radical house. And one non-pair who is alone, who has to stay inside the radical house, which is called the radicand. Okay, an easy way to do these variables, I feel like, is to write them out and find the pairs, because you're already looking for pairs in your factors. So if I take x to the third power, that means that I'm going to write out x times x times x. If I take y to the fourth power, that means I'm going to write out y times y times y times y. Or z to the fifth power is z times z times z times z times z. And then I'm going to look at them just like how I looked at my prime numbers. I'm going to say, I have 3 of these. Well, how many pairs are in 3? 1 pair. So those pairs can go on a date and be a coefficient for our radical. So remember, they're taking 1 car, so you write 1x. Then you have an x left over. Well, that x left over gets to stay in the radical house, which is called our radicand. The next thing with our y's are our y's, because there's 4 instead of 3, we're a little bit different. We have 1 pair of y's and another pair of y's. So they're not all riding together, so we don't just write 1 y. So this pair of y's is going to ride in the same vehicle. So we put y. And this pair of y's is going to ride in the same vehicle, so we put y. Well, what's the sense in writing 2 y's? Because y times y gives us y squared. So we put y squared. And we don't have any lonely y's with no date. Okay, so none of the y's are going to stay as the radicand because there's no date. So next we look at the z's. How many pairs of z's do we have? We have 1, 2. So we have 1, 2. So obviously that means I'm going to do z squared So I have 1z left. Well, that 1z has no match, has no pair. So he has to come below and be in the radicand. So our final answer, if you can see this, I'm going to rewrite over here. 3x y squared z to the second power times the square root of 5xz, which this is our bachelor matchmaking simplifying radicals. So I hope that you guys liked our story and our bachelor game with the radicals. If you liked it, say yeah.
Yeah.
You liked it? Good.
Yeah.